Okay, we've got some geezer here with his jetpack pretending he's James Bond. Although he's not James Bond, he's actually an estate agent on holiday in Magaluf. The water is sucked up through here and ejected downwards like that. Okay. State the condition necessary for the person to be stationary in mid-air. Okay. If that person is stationary, not going up or down or sideways or anything, if he's not moving, then the overall forces on him is 0. And that's the condition. So overall force, 0. That is the condition necessary for him to be stationary. That's Newton's first law. See my videos on Newton's laws for a more detailed explanation. But yeah, it comes from Newton's first law. Okay. B. The guy weighs 700 newtons. The jetpack is 140 newtons. And we're told that acceleration due to gravity is, we're going to use 10 newtons per kilogram. And we have to work out the mass of the geezer and the jetpack. Okay, so the geezer and the jetpack total force of 840 newtons. Just add the 700 and the 140. Okay? Now, what equation are we going to use? Well, we're going to use the force, if you're in a gravitational field pulling you down, is your mass times the gravitational field strength. G is gravitational field strength or acceleration due to gravity. It's the same as force is mass times acceleration. G, the gravitational field strength, is an acceleration. It's your acceleration due to gravity. You can use newtons per kilogram as units, that's fine. But you can also say that G is 10 meters per second squared. They're both acceptable units of G because G is an acceleration. Okay, so that's F equals ma, F equals mg, same thing. So, what do we have to do again? Right, work out the mass of both. Both add up to, the force due to gravity adds up to 840 newtons. We want mass, so rearrange the equation. Mass is force divided by G. So therefore the mass of both is total force of 840. We want it in newtons, so that's fine, don't have to do anything. And G is 10. So therefore the mass of both, 840 divided by 10, is 84 units of mass. Assuming you had that in the correct units and that in newtons, is kilograms. Okay, next, what do we have to do? Right, the geezer increases the force of ejection of the water from the jetpack, so there's a total upwards force of 1850 newtons from the jetpack. The force downwards due to the weight of him and the jetpack is still 840 newtons. Okay? We have to work out what his acceleration upwards is. So, that force is coming from the jetpack, and this force is coming from the weight of him and the jetpack. So the overall force acting on him and the jetpack is that minus that upwards. So that minus that is 1010 newtons upwards. That's the overall. Okay, So this is Newton's second law now. If an object has an overall force acting on it, it will accelerate, and the overall force is 1010 newtons upwards, so it's going to accelerate upwards. So we have to work out acceleration. So again, we're going to use force is mass times acceleration. So therefore, acceleration is force divided by mass. So that is overall force is 1010 divided by mass. Well, that hasn't changed, it's still 84. Okay. Stick that in your calculator and you get 12.023 something something something. Now in the question they haven't told you how many decimal places they want the answer to, so you have to be sensible. I would say I wouldn't cut it off as 12. Let's go to one decimal place. That's usually sensible and seems sensible here. So that 2 leaves that 0 alone. 12.0. Oh, units. Units of acceleration, like I already mentioned, is meters per second squared. And that's it.